mathematical model of biological neural network is a mathematical or computational model that imitates the structure and function of biological neural network. The basic building blocks in these models are neurons, which function very much like biological neurons. They all receive an input A, perform a calculation C, and produce an output O. During these calculations, each input will have a weight W associated with it, and these weights will be adjusted delta W during the learning process. The weighted sum of the inputs, denoted sigma I times W, passes through a startup function f, resulting in the final output O. The main purpose of these mathematical models is to better understand how biological neural networks work and to try to simulate their behavior. Through these models, scientists can study how neurons are connected to each other and how they transmit and process information. Overall, mathematical models of biological neural networks provide us with a framework that helps us gain a deeper understanding of how the brain processes and transmits information. These models also provide important tools for further research in neuroscience. In the 20th century, research at the intersection of neuroscience and mathematics began to shed light on how the brain works. In 1949, Donald Hebb first proposed Hebb's theory from a mathematical perspective. He believes that when two neurons are activated at the same time, the connection between them becomes stronger. This theory can be expressed mathematically as delta W underscore ij equals eta dot a underscore I dot a underscore j. Among them, delta W underscore ij is the change in the connection weight between neurons I and j, eta is the learning rate, and a underscore I and a underscore j are the activities of the two neurons. In 1982, John Hopfield further developed this concept and proposed the neural network theory. His model is based on the minimization of the energy of the system, which can be expressed as E equals sum underscore I j W underscore I j a underscore I a underscore j. Among them, E is the energy of the system, W underscore ij is the weight between neurons I and j, and a underscore I and a underscore j are the states of the two neurons. In 1986, scientists such as David Rumelhart and Geoffrey Hinton jointly proposed the backpropagation learning method, which brought the mathematical model of neural networks to a new milestone. The core of this method is to calculate the partial derivative of the loss function with respect to the weights and update the weights to reduce the loss. When we talk about neural network models, we mainly refer to technologies such as convolutional neural networks, CNN, recurrent neural networks, RNN, long short-term memory networks, LSTM, and generative adversarial networks, GAN. Bootstrapping language image pre-training, BLIP. The NIST dataset, in particular, considered the Hello World of AA, contains images of handwritten digits. Jan LeCun and others introduced a technique using convolutional neural networks on this data set in the early 1990s. These discoveries and technological advances paved the way for the further development of neuroscience and have had a profound impact on modern artificial neural network technology.